Hello and welcome to episode 139 in this series where I'm programming an NES game live on Twitch from scratch. Let's get right into this. Oh, I even pressed the right button this time. Cool. So last time we were working on using tile to generate our map and taking that map and turning it into a collection of metatiles that we were first generating a PNG for, and then once we generated the PNG, we turned that into an indexed image, and the indexed image was then used to generate the metatile file. One thing that I forgot about up until today was that I think there was some sort of issue with the way that the metatiles were being created in terms of the colors. Like, it was using multiple palettes even though it should have only really needed one. So we're going to look at that first, and then after that what we'll do is we'll work on changing the way the metatiles are loaded. Right now they are loaded from here. We have these metatiles that are pre-composed. Hey Matt, how's it going? And then these metatiles are loaded and used when generating the final data. But I don't want to do that anymore since we're composing the metatiles dynamically based on what's in the map here. I want to just simply use those metatiles, and what we can do is we can populate the structure that would normally be populated by reading in this file, and then just kind of work from there as we would normally. So let's start by taking a look at the metatile that gets generated. So there's this one for the water, and then there's this one for the wavelet, and these were okay. Actually, I cleared out the map, and now that I'm thinking about it, the issue was when I got to some more complex imagery here. So let's go back to this, and let's take, I don't know what we're going to use. Let's just take the house, because that was one of the ones that seemed off. And then let's grab a grass tile to just kind of round it out for the attribute table. Not that we necessarily care about that right now, but there it is. So let's export that now. Replace that. And let's rerun this. So we should get the water tile, that's fine. And then we should get the little wavelet tile, and that's fine. You can see we've got just the three colors here. And then we should have our next one, which I believe, well, that's okay. So that's, I mean, the colors are not exactly what I would have chosen necessarily in the translation. Like the green color here is kind of not great. And that's down to the conversion of the RGB values from the PNG over to the NES palette. So we can, it's hard to get an exact match. That color that Jordan chose is a little bit unusual, or doesn't quite match, but that's okay. I mean, the point is that that looked okay. There was no issue with the way the layout of the palettes were or anything like that. So let's take a look at this one. That actually looks good too. Am I going to have a problem reproducing this now? I wonder I wonder if the problem is specific to if you have too many colors in the metatile. Like maybe I made a mistake when I was laying this out. Nope. Okay. Although, yeah, you know what? That's probably what it is. Because if you look here, I mean, that looks reasonable, right? You've got your 4 tiles here. Let's see. Just want to... Can I change to a... Yeah, there we go. So we've got the black, we've got this brown, we've got this orange, and then we've got this green. So it is a situation where the problem is the number of colors. And what's happening is it's choosing. It shouldn't be a problem because this 0E is the same as, you know, the background color, which is fine. But let me see something here. If I do that, yeah, so it's not even... All right, so the problem is that we have overlapping colors that aren't being matched. And so we're running out of colors, so it's bumping it up to the next set of palettes, which obviously doesn't work for the backgrounds. So this should be as simple as just having it check when it's indexing the image, checking to make sure that the color isn't the 0E color. So it iterates through all the colors, it checks the distance between them, and then whichever one is the shortest is what's selected. I guess what we should do does it compose? I don't remember if it composes. It doesn't compose a palette from that. Composes the palette from in this. So there is no initial sprite, so we're just going to iterate over the thing and we're going to look at the palette. Load image palette. Isn't that this? Or is this a different load image palette? This is a different load image palette. Okay, so it's getting the 4-color palette from the image, and then it iterates through that. But it never bothers checking the background color. I mean, I guess there's, for sprites that won't work. But for backgrounds, it's totally fine, right? Because for sprites, the 0 index is a transparent color. So what we can do is something like and then add well, I mean, I guess if you're passing a sprite, I'm going to make this explicit just because I want to check all the places it's called and make sure that that is going to work okay. So like in here, this is for a metatile, so we're going to say no, it's not a sprite. For this one, PNG to character, this is another one where it's just doing a raw conversion to character data. I'm going to say no on this one too, although, yeah, because I mean, if you're not, yeah, I think that makes sense. Okay, so that also helps, I guess. All right, and then this is also false. So it's never used. That's never actually used for sprite data. Interesting. I wonder why that is. Well, that's something to keep in mind. I didn't change this loop to use initial index like it's supposed to. So now it should work because it should check palette color 0 for 0E properly. And we shouldn't jump to a secondary palette for images that don't actually need it. So that one's fine. That one's good. That is good. That is also good. That is... It's fine. It's not right. I wouldn't have done it that way, but it's technically okay. That makes me suspect that this still isn't fixed. And I am correct. All right, so... if it's a sprite, use index 1, otherwise use index 0. Loop through I for 4. I believe this is for all 4 palette entries, right? Because 10 palette, final palette. So started 0 for that, and started initial index for J. And then what is final palette? Final palette is a 60, yeah, and then that's used. So if temp palette k isn't equal to -1, so we've set it to some value. Oh, do we? Huh. I wonder if this, when we come in, color 0 is set to -1, and then we convert it later. I wouldn't be surprised if I had done something like that. These are in 8s. Yeah, so that's -1. Okay, so that's why it's not matching, because it's not the right color. It's -1. So this is kind of... This is kind of dumb, because that basically doesn't solve the problem, because ultimately we're still going to have to write a test case to see if the color is 0E, or at least whatever our default background color is going to be. So let's see. So let's see where we actually do that conversion. I forgot that I was doing that despite seeing all these -1s everywhere. I think we can get rid of that. Well, let's leave it alone for now. I don't remember what that code does, but... Okay, so what is this code? This is the end of this method. Okay. So we're saying loop through the final palette, and if it's -1, then make it 0E. Otherwise, use its actual color. So what we need to do is, let's declare a constant here, call it default background color, and not bump the microphone. And then, now that we have that, what we can do is we can say this actually, so this is actually generating, the palette, and then we're comparing the values. If image 0D is 65, right? Wait. No, of course it's not. What is 65 in hex? I can't type. 41. Why are we... If this is 65... Continue. Oh, is that an unused color? Okay. So we generate our 64-bit color map. And then we shift off the bit. Right, so we're going through each bit in the color map, color count, skip background color. Right, okay, I remember what this is doing. So this is giving us, if you remember way back in the beginning, this call will generate up to a 16, a set of four color palettes. And so it's got to skip for every 4, it's got to skip the background color. But the thing that it's not doing is it is not it's not checking to see if it's the default background color, which we don't need to explicitly include. So like right, we do this. We still need to shift 1 off. But it shouldn't increase the color count, and we shouldn't bother doing anything with it because we know we're going to have it no matter what. This would actually matter. I wonder if this one is being used. This one's probably being used by the sprite code. I mean, I could be wrong, but let's do this. Because this, again, it matters. It matters for sprites, even though it doesn't matter for backgrounds. So let's see what gets broken. Only one place. What is this? This is just this, which doesn't get used for sprites. That's really interesting. But I know I used load image palette elsewhere because, yeah, PNG to sprite. So convert image to index, load, okay. Oh, but it's using initial sprite set to true. How come this didn't come up? Why didn't this come up before? All right, so we got to change both. More so for the other one. And is not sprite. Right, because if it is a sprite, we would, even though it's bad because we're wasting a color by using the background color, we don't want to do that. So, yeah, the bool is sprite. I think that should be, let's see. That one's fine. That one's fine. That one's good. Also good. That one is good too. It's just using the two colors, the orange and the brown. And that's still not right. Interesting. Why? All right, let's retry this. So it's going to be the grass, the wavelet, one corner of the house, the other corner of the house, the last corner of the house, and then, oh, I overdid it. All right. So, grass, wavelet, one corner of the house, second corner of the house, third corner of the house, last part of the house. Let's go into this. So this will iterate through the color, the whole thing, and then let's see if we take this value, color map, and let's grab the value and look at the binary. (251)82208 binary. Okay, so let's see, that's 8. That's 16. It's 30. No, that's 24. 20. So 1, 2, 3. I only see 3 colors here. Yeah, which makes sense. It's 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So it's going to be this. Wait. 0E is... Huh. Why... Why is bit 14 not... Or is it set? That's bit 8. So that's going to be the 16th bit. 15. Or is it 14? 9, 10, 11, 12, 13, 14. Well, it's going to be... Okay. So, yeah, so... That's not right, though, because that's like 52. What is that? 64. 251.82208. No, right, because okay, because we're just shifting the bits into this. So that's gonna be 4, 8, 12, 16, 15. Or is it going to be color 0? Is it off? Is it 14? I guess it could be. I don't... Confusing myself with the... I guess because this would be color 0, the first bit. So, okay, that is 14. So... So then... It's the 15th bit, but the background. Okay, so it's an off by 1 problem, I believe. Or is it? Background color is 0. Background color 14. Background color 0 is going to be bit 0. Background color 14. Then should be bit 14. Oh, no, wait, it should be bit 15. This is what happens when you try to do something clever that you can't reason through right now. All right. This is color 0 or first index, so that's going to be bit 1, right? So yeah, so the 15th bit is for color 14. So this is going to be off by 1, or something is going to be off by 1. So J is going to be the literal color. Or how many times we've iterated through. It's going to be, so the 0th time we've iterated through would be for bit 1, but bit 1 is for color 0. So this should be okay. Is it just... It's not something stupid like that with the order of operations, is it? Kind of... Oh. That would be silly if that's what that was. Okay. Water, wavelet, first corner, second corner, third corner, and this is the fourth corner now. And if we look at color map 1537, that bit is set to 1. So we skip it and we move it off. Palette destination currently has nothing in it. Color count plus color map and 1. Right, so if it's set, we add to the color count and then we shift off the color map and then... All right, so if we come out of this, our palette is FF1718FF. Is this the wrong thing? I think it is. I think that was 1 too early. Potentially. No. Maybe I was. Let's no, I wasn't, but it's still wrong. Crap. Water. This is the wavelet. 1 corner, second corner, third corner. This is the corner we're interested in now. So we're going to go through the image tile by tile. going to iterate through and get to a point where we have a palette. So that is set there. And now we're out of this, so we have color count is 3, and our palette destination is only 2 colors. Why? It's interesting because 1718 and FF. What are those colors? 1718. So those are okay. That's what I expected. But we haven't, maybe it's because we haven't gotten to the grass yet. So they're really, because yeah, if you look at this part of it, this doesn't have the green, this does have the green, and then this is basically all green here. So that kind of makes sense. And then what we're doing is we are looking for palettes that match. Oh, I wonder if that's the problem. Well, it shouldn't. Okay, no. Okay, so it's 2 things. So it was right about the initial index thing. Because what's happening is, I forgot. So what we're doing here is we're iterating over all the palettes that we've loaded up and looking for the colors to see if they're in any of the palettes, because we want to make sure that we have all the colors we need. And for the reason I said before, we're skipping the first color, which means that even though we could compose the palette properly in load image palette, this one, when it comes to this, it's not finding the color that it's looking for in any of the existing palettes, because it's not looking for the color in the first index. So if the color doesn't equal -1 and the colors are a match, I mean, I guess what we really need to do should I be doing that here? Setting that like that. Oops. And that way, final palette go -1, temp palette that, final palette free. Oh, these are how many free spaces are in. Even this probably has to change, doesn't it? Because same thing here. These loops are ugly. But, as I said before, given the small amount of data we're working on, it's really not a big deal. It still makes me cringe a little bit. Okay. So we got to initialize it a little bit differently. It's not going to let us do it, is it? Okay, I didn't think it would, but it's also worth a try. So if is memset final palette free size of no 3 size of final palette free. Okay. Of course, there's a typo. Now there's 2 typos. Let's see. Let's make sure that that is still working correctly for the ones that were okay. I don't see why. Oh, okay. So that's wrong. I know why it would be doing that. I'm not sure what I changed that broke that, though. If it doesn't equal -1, and it doesn't equal the default background color, if k is 0, is that right? Because if it, or actually just if, if it's not -1 and k is equal to 0, then that would be the first index, which we've set to the default background color. But in that case, we want to just leave it alone. Right? Or no? Temp palette K is not -1, which it could be for K0. So would that allow it to overwrite it and the values match? Well, the values wouldn't match, so that's not it. Is it this part later on? If it's equal to -1, then break. Otherwise, check to see if they match. And if they match, check if they match. If they match, then break. If they If the final palette is -1, that means we have a spot. So put the color in. The final palette is zeroed out to -1s. Okay. Didn't realize this was going to be such an ordeal to fix. Let me think about this a little bit, because I'm going through and making all these changes to fix this problem. For something where basically the issue is that we're encountering the use of a color that's being used for the background color, but we're not looking at it at all, because up until that point, up until the point that we're done examining all the colors, we don't know that that's the background color. Should we, instead of doing this, instead of doing what we're doing, I'm going to back out these changes, because it just feels like I'm overcomplicating the way that this needs to come together here. I just need to look at it a little differently. That default background color thing is good. Okay, let's leave this here like this. So we do care if it's a sprite or not still. And we care about that because we want to skip processing it in the same way that we process the other colors. Destination. We could, if we do this, does that do anything? That sets the default background color. We skip to the next color. that was set. And the only other thing we need to do, we still need to check if the color is the background color. Right. So if we're processing the default background color at this point, we just want to shift that off and continue, because we know that it's going to be set anyway. If not sprite, right? If it's not a sprite. Hey, Deadeye, how's it going? Alright, so if it's not a sprite and we're hitting the default color, then just leave it alone. Because we know that we can rely on that. So, and then we're setting the background color there. And then do we care to process this any differently? Let's see. So we got to pass if this is a sprite or not still. But we're going to process this for all the colors except for index 0. Yeah, I mean, again, for if it's a sprite, it matters. If it's not, it doesn't. I feel like I'm just rehashing some of this, but it's just because I'm still kind of trying to figure out what's the right approach for this here. So we've got the initial index set. So we're iterating through now all the colors if it's a metatile versus a sprite. So when we come out with the temp palette, then the color should be set. For final palette, these are all set to -1, but if it's not a sprite, am I doing this right? Oh, I knew there were supposed to be 4. I skipped one. All right. Equals default background color. So instead of just having -1, have that set to the actual default background color so that when we iterate through, we find the color. Found palette index. If 3 minus match palette count is less than or equal to final palette free, this is again looking to find a spot in the final palette, and this is This has to start at the right index based on if it's a sprite or not. But now this should work correctly. And then this should this be 3 or 4? Is less than or equal to 3 minus match palette count. If there are 3 colors, there could be 4 colors. Okay, so we need another one here. Other way. Other way. Oops. Free max value. And again, this is all because it matters if it's a sprite or not for how many colors we can actually have. So this would be 4 minus the match. Okay, scoot through there, iterate and compare. So we would be looking at the first value. I think maybe finally we have that right. And then it will iterate through the final palette and find any that have not been set. Hey, Yamato Special. Just started watching your NES videos and excited to get to video. Hello Mario, learn some more about getting something basic going on. Cool. I'm glad you're liking them. I'm glad you're getting something out of them. If you have any questions, definitely let me know. I can answer them here, or if you want to post on the you know, on the video itself, that works too. Try to answer relatively quickly, but you know, depends on how things are going in general with work and life. All right, I think that might take care of it finally. Let's see. Let's just make sure these are all looking correct. So we'll go through them again one by one. So, crap, why? All right, let me look at these color values first before. Oh, wait a minute. You know what? It didn't write it out, so maybe it's okay. Whoa. That's not okay. I don't know how that's possible. That one is okay. That one is not okay. Okay. What am I doing wrong here? That one is sort of reasonable. The color palette is right, but now the indexing is all wrong. That one is surprisingly fine. And that one is not. I feel... So let me simplify the map here. I'm really excited to see what I can do as far as pushing the NES capability and doing some modern game recreated in NES, but simplified to be feasible for NES. Of course, done some 2D before, but nothing big, and I've dabbled in 3D VR a bit too. Cool. What did you do in 3D? Was it like with Unity, or did you do OpenGL and Vulkan or something like that? What were you doing? What the NES hardware can't do. I mean, there are a lot of things it can't do, like, you know, raster graphics are particularly tough because everything in the hardware is tile based. So, I mean, you can do it, but it requires a lot of a lot of trickery and messing around with how you're drawing and timing things really precisely. And then people do crazy things like use that to do, you know, sort of like ray casting, like old school 3D games. Unity for 3D and VR. Cool. But I mean, you know, those limitations are more, you know, there are hardware limitations that are purely just limitations as a result of how you have no choice but to work within the constraints of what the hardware can actually render. Right? So like the colors, like the stuff that I'm trying to struggle through right now with the colors is one of those things, because you can only do, you know, 3 colors on a background, and yeah, F to FF is a good example. And if you check out Vectrix28, he posted, I guess it was a few months ago now, a really cool video of his raycasting engine for the NES. But, you know, there's a lot that can be done by tricking the hardware and you know, working kind of on the fringes of what the hardware is meant to do. It's all kind of a matter of how creative you are and how precisely timed you make things, and you know, and even then there's still limitations because of just, you know, there are only certain colors it can generate. Even if you can overcome the challenges of you know, displaying more than what should feasibly be possible on the screen at any given time. Like there's a Deadeye, you might remember what I'm talking about. I can't remember what it's called, but there's some sort of ROM that you can use. I think it only works properly on real hardware, but it's a ROM that will display the entire NES color palette. And it does that through various bits of trickery, because there's things that it's doing with like the intensity bits, which are used to intensify certain colors on the screen, and so it's got to flip those properly at the right timing to get the drawing of those other colors correctly. I'm a NES dev, complete noob, so a lot of this is over my head currently, but I'm excited to learn. I want to make a simplified space game I enjoy on Steam. That's cool. I mean, yeah, and certainly, like I said, you ask questions of me and others in the community. I don't know if that was by match. Let me see. I know. We'll take a brief tangent here to let my brain regroup. MacB? Is that who? Let's see. The Blarg full palette demo. That's what I'm talking about. And I believe... Oh, it's not working? Oh, man. It looks like it's not loading here. There's one by Biscuit and one by Drag. Oh, but these are just tools for online. I'm looking, there's a ROM, and it's this one, this Blarg one. Blarg full color palette. It's not working. Yeah. Anyway, so that ROM is interesting because it's really, it's surprisingly complex for something that should be relatively straightforward. So it generates something like this, but you know, emulators that are not good will not generate the color palette properly. They'll have issues running the ROM. I can't say that I've even tried it on the NT Mini or the AVS by Retro USB. I imagine they're probably able to do it because they're pretty accurate, but that's like I said a moment ago, I haven't tried them, so I couldn't tell you. And for something like that, you know, just the slightest timing being wrong will mess it up. All right. So what the hell am I doing wrong here? No internet connection. So actually, Antoine from Broke Studios, who made Twin Dragons, which is an NES homebrew if you don't know it. He's also an electrical engineer. He designed a cartridge that has built-in Wi-Fi on the cartridge. And so there are some folks working on doing that exact thing on online multiplayer on an NES game. So they basically, the Wi-Fi device is built into the cartridge, and the mapper that controls how the NES sees the data on the cartridge for playing the game, in this case, is pretty powerful, and it uses, when you write to the mapper, it will actually communicate with that Wi-Fi module to allow you to do online communication with the server. What does the NES Doom project do for color palette displays? Is that one of those things where they're basically running Doom on like an Atmel CPU and just using the NES as essentially like a video interface? Oh yeah, no, that's true. I should have mentioned that. So Paul, who runs Infinite NES Lives, is working on a cartridge in parallel with Antoine from Broke Studio to build his own version of the Wi-Fi cartridge. But Antoine's is, I think, a little bit further along. I could be wrong. It's been a while since I've talked to anybody about that. But the one that Broke Studio built is being used by Morphcat Games for Super Tilt Bros, is that right? I might be, yeah, so Super Tilt Bro. Yeah, so they built a back-end server with the cartridge and stuff like that. Yeah, so you know, the thing is that the Wi-Fi hardware is relatively cheap. I mean, if you look at the cost of a cartridge these days for what's involved, you know, the board is, you know, whatever the cost of the board is, and the Wi-Fi module hooked into the board is, I think, you know, like $1 or $2 more at this point because Wi-Fi is so ubiquitous. It's super cheap. So the hard part there is making it meaningful and useful to the NES because the NES CPU is super slow. Having it communicate to the cartridge Wi-Fi board directly is not super helpful. And so basically the mapper chip that sits on the cartridge that the CPU talks to is actually what is smart enough and powerful enough to talk to the Wi-Fi module to send and receive the data. And then the data is available on the, is either sent through I don't remember if it's sent through a RAM range that's read by the mapper or if it's just bit blasted in by writing to addresses to the mapper. That might be how it's done, and then it's read out. I don't think it's using direct memory access on either direction. But yeah, it's super cool, and they've made really great progress with it. It'll be something to see, if we get some more like fully fleshed out releases that people can buy with Wi-Fi cartridges. NES Doom is using Raspberry Pi in the cartridge. Yeah, so we'd know if it's using dithering by just looking at it. So let's take a quick look because I don't remember. If nothing else, it's just kind of translating the colors over to the palette for the NES. So there it is. So if we look at, yeah, that looks like dithering to me. Deadeye. Go away. I mean, those patterns, that color pattern there is pretty consistent with dithering. So it's kind of like doing its best to match whatever it can. And it's probably using, well, I shouldn't say that. My guess would be, knowing nothing about how it works, is it's using 4-screen mirroring, and the 4-screen memory is what's being populated with the actual imagery that's being then displayed. But who knows? Yeah, Kevin from Kahan Games is working on an online game, but I don't know where that sits in his backlog, because he's got a bunch of games that he's been working on, including that new Pawn Stars one. So I know that's wrapped up at this point, but he's always got a bunch of projects that he's working on. And back in this past summer, I was talking to him about some stuff that he was trying to work through with the I think it's called the Rainbow Mapper for the Wi-Fi cartridge. So it's interesting. It's pretty amazing stuff. All right, so what am I screwing up here? What am I missing in the way I'm doing this? Should I just be See, the problem is that I can't even do this index image tile the way I thought I could maybe do it, because we're not setting the color until the very end. I was wondering if I could do something where I just say, if the color is the background color and it's not a sprite, then just ignore it to the very end. I guess I could do what I'm doing here, where I'm actually setting that value hard-coded instead of -1 for the final palette. Let me go. Let me change some of this stuff back because it's obviously not working. This part is okay. Let's go back to, you know what we can do? We can just take advantage of this being that. Leave these alone. And then basically say, okay, if the temp color is -1 or default background color, then we don't need to look for it because we know we're going to have it. And then does that simplify what I was doing here? And the initial index stuff is kind of just, we'll go back to having that set to 1. Let's see if that has any positive effect. Like I said before, I didn't realize this was going to be such an ordeal, partially just due to me even being kind of dumb about how I'm doing this, to be honest. It's really frustrating when that kind of stuff happens, but sometimes your brain just does not want to cooperate with whatever you're doing, and it just kind of eludes you for a while, and then afterwards you're like, wow, that was stupid, that shouldn't have taken nearly as long. But here we are. That looks better. That is also good. And that is also good. Oh, you know what I didn't do, though? I didn't re-export the map, which is why it has all these same tiles and palettes. That's unfortunate. It's because I was talking at the same time. I didn't think about the fact that I needed to export. So that's all good. So it's still wrong here, although it's less bad. I'm sure I'll get there after a few more of your videos, but are you able to use C++ code, NES games, instead of purely assembly language? Not C++, but you can use C. There are some compromises in doing that, because the compiler is not particularly smart, and so you end up with some things that need to be optimized by hand in assembly. But I know several people who use C, and then when it gets bad, they rewrite their C code optimized in assembly, just because it's technically faster. I mean, at this point, honestly, the assembly language part hasn't really been the issue for me. But that's just me. So if you find that you'd have an easier time writing your code in C and then optimizing, loops or something that are not running efficiently enough in assembler, by all means do that, because, if it means you finish your game, if it's the difference between you finishing your game and not finishing your game because you don't feel comfortable with assembly or you don't like assembly, then I'd say that's a pretty compelling reason to use C. For me, I don't care. I actually kind of get a kick out of using assembly because I don't know. That's how my brain works, and so I don't mind using it. It hasn't been too much of an issue other than with signed comparisons, where that was something that was kind of throwing me for a loop, because the way you do the signed comparisons on the CPU, at least at this point, is still not intuitive to me. I'm sure if you understand signed binary digits better than I do, then maybe it makes more sense. But regardless, yeah. How do you write some in assembly and some in C? So you can do something like I'm not sure this is actually the right syntax for x86, but so like in x86, you can do this too. Like you can say, move AX5, move whatever, right? You write your assembler code in line. If I take a quick look for you while we're talking about it, C65 inline assembly. Here you go. So what you do is you have your C code, and then you can do this directive, this ASM directive, and inside you have in the string you can actually write your assembler directly into that. If you are trying to do something like that, you probably, I think he does his stuff in C. Let's see. I believe he does. Yeah, so if you look up NES Doug, Doug's a good guy, and he wrote up these tutorials. This is how you do it in C. So he covers a lot of the same stuff, but he does it all in C rather than assembly. Yeah, nesdoug.com. Probably links right on his main page. Oh yeah, it's right on the main page. So just follow this too. I'm on mobile. Else I would have just Googled it, but I'm... Yeah, no, that's fine. Space of concern with C. I recall Doug saying that for jamming honey. However, Thomas didn't mention... Yeah, so I mean, again, the issue is that the compiler for the C65 compiler isn't the best. And it also doesn't generate particularly good or optimized code. It's functional, it works, but the other part of it is that the 6502 is such a limited CPU. Like you literally have 3 registers to work with, right? You have A for your accumulator, and then you have your 2 indexing registers, which can only be used for so much. And so when you do something like when you're coding an assembly by hand, let's bring up some of my code here for a second. When you are, doing your code by hand, like, I guess this is an okay example. I'm doing a loop here, right, where I'm looping through my memory, and I'm clearing it out and initializing things how they need to be for the game, right? And because I'm doing this by hand, I can control what registers I'm using. I know what registers I'm using. And so I can be pretty efficient about how I want to do this, and, do all of this stuff in register rather than relying on a memory-based counter like you would in C. Like in C, all my loops are, for I is equal to whatever, or J is equal to whatever, and I'm looping through, and then the compiler knows how to turn that into potentially using a register, And x86 CPUs have way more registers, and are also faster and have cache to further speed things up if you're using RAM, so that it doesn't actually have to go to the RAM. It can use RAM that's, right on the CPU, which is, several orders of magnitude faster than your RAM, no matter how fast your RAM is. So, on something like this, it doesn't really matter anymore, unless you're doing something that's super timing critical, like you're writing. I imagine the guys and girls, men and women who work on games like Spider-Man on the PS4 or PS5, they care about that stuff because, they're rendering New York City, doing animations for Spider-Man, all the characters on the ground. They're running the ray tracing for the reflections and the shadows, everything. And they're rendering out 4K frames at 60 frames per second. They care about that stuff, right? For what I'm doing here, and for most normal programming stuff that people do, nobody cares about that. On the 6502, you don't have cache. You don't have any way of accessing the memory quickly. And so to do a loop like for I equals whatever, that turns into a lot of code that's shuffling memory back and forth into a register, out of a register, into a register, out of a register, just to do something really simple. Because the compiler is kind of taking the edge case of the registers have to be used when they have to be used and can't be relied upon to have a value at any given time, because the compiler is not smart enough to understand what the rest of the program is doing. Like, I'm smart, in theory, I'm smart enough to know what my code is doing at this point in time, so I can look at this and I can use my X register and I can say, or my A register, and say, I know that it's safe to do this because the non-maskable interrupt that happens when we're drawing the screen is not on right now, so I don't have to worry about any of these being modified by that. And even if it were, the non-maskable interrupt can store and preserve those values as it occurs, so that when we come back to this code, it doesn't break anything. The compiler is not as smart as that. Even when I'm at my dumbest, sometimes the compiler is not that smart. And again, it's because of the limitations of the CPU and stuff like that. And CC65 is an adequate compiler. It's not like the compilers that have been worked on for x86 and x64 and other high-end business-related architectures like ARM also, where you have people being paid lots of money to write good compilers. So there's, you gotta just kind of be careful and look at what's going on. If the code is not, if what you're doing isn't working for some reason or is really slow, then knowing the assembly is helpful, because you can actually look at, like, okay, what is this doing? And it's like, oh, the compiler is being dumb. It reads from RAM, increments the value, and stores it back to RAM right away, and I'm not doing anything with the register later on, so this is a total waste of cycles going into and out of memory. I'll rewrite this in assembly so that, I can just use the register directly and save a bunch of cycles, and it works fine. Sounds a lot like how the developers tackled Crash Bandicoot on PS1. They described it as pages in a book that they kept shuffling. Yeah, I mean, and that's how that's a good analogy that they used. I mean, and also, you figure that's how things like virtual memory work on your PC. Like, if you've got and that's why it's slow. Like, if you've got a machine that only has 16 gigs of RAM, and I say only in air quotes, but only has 16 gigs of RAM, and you're doing some sort of intensive photo editing or movie editing or something like that, where you need a lot more RAM than that, the system can still run even though it needs more RAM by, offloading portions of the RAM that aren't in use to your hard drive. That's what, if you've ever messed around with Windows and you go into your performance settings and you look at your virtual memory file, right? That's what that is. It's how much space are you going to give up on your hard drive to allow the system to page out stuff from actual memory while it's not in use. And then when it becomes in use, then you've got to do the whole thing where you shuffle it out, shuffle the stuff that's not in use out again and bring the stuff that you need to in. That's called a page fault. And that's slow because it's got to go to the hard drive multiple times. One time to store off the memory, another time to load in the memory, and hopefully you have an SSD where that's not as bad, but it's still bad because it's still way slower than RAM. If you have a spinning disk, you're talking about an eternity of time for the CPU to get that stuff. So, having virtual memory is great for the sake of like allowing your system to run when you've overcommitted, but it's better to have more efficient software that doesn't need as much RAM. So let's see. So this is still broken in that last tile. I guess I'll go back to the map the way it was. Since I didn't export it anyway. So it was something like this. Right? So what is the deal? I think it's also because I'm assuming that there are only 3 colors that are available when technically, again, for backgrounds there are 4 as long as one of those is the background color. Which is part of what I was doing here in this code. So this is still, let's do this. We'll piggyback on this logic here. So we'll set that to 4 because then we can say we have 4 colors, so it shouldn't jump the shark and go to the next palette. So let's see. No, don't do that. Let's see if this broke anything again. So far, so good. Still looking good. Still looking good. Crap. All right. I really do want to just export this and just see what this looks like here, because I'm really not sure why it's broken. I'm sure it's going to be one of those things where I look at it and I'm just going to be like, well, that's dumb. and feel super embarrassed about how much time I wasted on this, but that's okay. Hopefully we all learn something. And if not, then I'm sorry. All right. So let's restart this and see, first of all, it should be the first tile it tries to export because I put it in the top left corner. Great, and it's consistent, so that's good too. Let me, just for the sake of not going on a wild goose chase here, make sure that, oh, damn it. That is not what I meant to do. Okay. So, that is consistent now. We can troubleshoot it, so let's take a look at how it's actually processing the palette to understand what I've screwed up. So, come on. Alright, so I've got my background color set. And final palette free now consists of 4s. So we're going to iterate through this thing tile by tile. And what we're going to do is we're going to load sprite. It's false, right? Yeah. So we've got our color map. Okay, so destination palette gets set. And then if it's not a sprite and J is the default background color, which it wouldn't be yet, then we would shift off the bit, but we got there by me jumping the gun, but that's okay. That's fine. So we're going to come out of this now. Color count is 3. We have 17, 18, and -1 because we only set those first two. Okay, and that's fine. It actually did want to set 0E, so that's good that it didn't do that additionally. So now when we come out of this, we have our temp palette, which has reasonable values in it. And so we're going to go through and look at the final palette. We're going to look for, we're going to check to see, did we get this color already? Oh, so this might be where it's going wrong, because it's not going to bother looking at index 0. Which is a problem, because index 0 is what we want to look at. So if we were to do that, that was what we were doing before. We were starting at index 0 and we found the value that we were looking for. So we said we matched the palette, and then have we matched all the colors in the temp palette with the final palette? Palette count is, so the problem, I guess, is that palette count is also 3 when it should be 4. Well, I add to color count here, so that's okay. Palette count is color count. See you later, Deadeye. Thanks for stopping by. So we add the color count. That gives us how many colors? So that would give us so it's really the color count wouldn't be 3 in that case. Technically it would be 4, but okay, let's see here. And then we're seeing if the matched palette count is, that's how many we matched. Have we matched all the colors? Matched palette count. Count that up. Found palette index. So that assumes that the palettes are identical. Yeah, so it's a shmup. I don't know if I have a ROM that's working right now. Where's my controller? Oops. Been cleaning and reorganizing things, so it's a little bit of a mess. I'll do it in this USB. Sorry, I didn't have a gamepad plugged in here. Let me set up the inputs here. I'm just using this Xbox 360 controller. Even though I don't like the D-pad, never have. Yeah, so it's not, this is, the background is wrong, but it was working a lot better. Chance of a 10-second recap. Yes, so the 10-second recap is that my palette generation stuff is totally wrong, and it's not working, and I'm trying to figure out why. And that's what I'm up to. So I'm at a point where it's better, but it's still not completely right. So that's what you missed in the last hour, I guess, since you were gone. This turned out to be, yeah, this is a pre-processing tool that's taking the map from tiled and generating 4x4 or sorry 2x2 metatiles, and then outputting those for the game. It used to be that I'd manually create those, but now that we've switched to kind of using 8x8 tile sets, I wanted to pre-process them to optimize the tile sets so that we could have something a little bit more compact than 8x8. And you know, the tile set is pretty compliant with the attribute grid, but I'm having other issues with this right now. So yeah, so that's where we're at. Trying to figure out where I've gone wrong with my palette processing for the JPEG that's used, because it loads the JPEG, it converts it to the NES palette using a palette that's loaded in the tool, compares the RGB and selects a color that's closest to the NES palette, and then it turns it into an indexed image that's then output. So the level designer doesn't work in 16 by 16 metatiles. Yeah, that's what I'm trying to do. We had talked, the artist and I had talked about working in 16 by 16, and we just thought that it would provide more flexibility to have the ability to work in 8 by 8, and then, you know, if we run into some sort of limitation, we can flag it and then kind of work back, you know, how to make it work. And then there's a lot of advantages to doing this, because you have the ability to say, okay, well, you know, so this is one metatile, and then you compare the individual tiles from the metatiles to one another, and you can say, well, those are exactly the same. I don't need 10 tiles that are exactly the same, obviously. And so then from there you're compressing not only the space into metatiles so that it's not as many 8 by 8s, or same number of 8 by 8s, but you're not storing the raw 8 by 8 tiles, but then also the individual tiles are boiled down to the bare minimum, and your metatiles are just referencing just a palette of 8 by 8 tiles that, you know, get generated by the tool. So I was hoping to work on the actual metatile stuff here, but the problem is that, like I said, something in the way that I'm processing the palettes was based on the idea that we would never look at the 0 index for the background color, but that is wrong now, and that's breaking things. So I didn't realize how broken it was until I started doing this. So that's if it's an exact match. 3 minutes match palette count is less than palette free. Right, so what this is doing is it's looping through, and it's basically saying, okay, can you find an exact palette match, right? Like, do we have a palette where every single color we want is in that palette? And if it is, then we don't have to do anything. Otherwise, we have to update the palette if there's free available spots to contain the color, right? And actually, now that I'm explaining that, this part is probably wrong, because, well, it's definitely wrong, because it shouldn't be saying there are 4 free spots. There's 3 free spots plus the 0 indexed color, background color. So there's that. So that makes a little bit more sense why that might not be working. And then if this is a sprite, then we want to start with 1. Otherwise, we want to start with 0. So that would mean we would check and see if the background color matches, which it might, and then that would be considered a match. And if the match palette count is equal to palette count minus 1, let's see. Otherwise, we look for a free spot. I would assume we would probably want to check for... No, it should always find the background color. So let's do this. Let's come into here. match palette count. Palette count is 3. So it matched some of the colors. Matched one of the colors. So final palette free says it's 3. Match palette count 1. So this assumes the color is that's probably wrong too. Why isn't that working? Oh. Come on. Stop doing that. So the color is 17, so it doesn't have that in the final palette. You can see that over there. So we're going to add it to the final palette as one of the colors and break out. And then the next color is 18. So that's fine. What is the color that it's using now? J is 2. 0, 1, 2. Okay, 18. So it updated that. And then that's the end of that. So we found palette index I. Okay, so that's good. And then we index it with the palette index that we just created, and that's all good. So now we have this new palette. We matched some of the colors, or we matched one color, but that's it, which is the background color. So we're going to come in here, palette count. Well, that doesn't make sense. The C0 isn't, 0C isn't used anywhere. So that's weird. How did it say that it meant? Oh, because, right, because it is, this is not correct anymore. Or it is correct if it's a sprite, but it's not if it's a background. Okay. It's amazing how the thing that you think might be, you know, easy or straightforward ends up being way more complicated. All right, so of course the memory addresses are no longer the same. So that's our first palette, and then this is our final palette, and where can we loop? We're going to loop back around. Yeah, we'll loop back around. So this is our second palette, which is E0E0C. Match palette count is 1. Palette count is now 2 minus 0. So it didn't match everything because it only matched one color, which is the background. And then, crap, this is wrong. Right? Final palette free. This is 1. Match palette count. What's going on? Matched palette count. I just can't type. Why is that undefined? Is it because it's in this loop and not... Okay, so that's why. So, whatever, that's fine. The value of this is 1. So, what was it? Can I... Sometimes... Can I do that? No. Alright, we'll restart this because I really want to see what that was. So in this case, it's 1, and we have 3 spots left. And now it's 1, and we have 1 spot left. So match palette count is 1. So that gives us 2. Why is that? If 3 minus match palette count, that's how many colors we have. Minus how many palettes we matched. Oh, that's how many we didn't match. Right, so that gives us how many we didn't match, which means what? So we matched 1 color of... Yeah, show me temp palette. We matched 1 color of 4 total. It was just the 0E. And 0C wasn't matched, right? So we didn't find an exact match of colors. And but the thing is, let's see. There's just 1 color that's needed. So initial index is 0. Temp palette is not -1. Hi, Miak. It's going okay. I'm kind of struggling through some weird issues that I'm running into with this, with generating palettes. It took way long. It's taking way longer than I expected it to. Partially because I'm not understanding where this is going wrong. So let's see. So if we're looking at the palette, if the palette is not, value isn't -1 and it matches what's in the final palette, we get a color match. So we get 1 as our value, which makes sense. You know what the problem is, though, is it's assuming that if it doesn't match, it's assuming the worst case scenario here. It's saying if only 1 matched, do we have enough to take on every single color? And of course we don't, because we've already populated it with 2 colors. We only have 1 more space free. So what we really should be saying is, instead of 3 minus this match palette color, what we should be saying is, okay, how many total colors were there in the template itself, or the temp palette itself, because there are really only 2 colors, right? So this should be 2 and this should be 1, which it is, and then we would get that it's smaller than or equal to what's available. So we need something here where we say, where we spell it correctly first. And then we say, okay, if it's not -1 and it matches, then we've matched it. Otherwise, let's do this. I'm going to break this up a little bit. Because we only care if it's not -1. But if it matches, then we do this. Otherwise, we do actually, this is a bad name. It's just this is required additional colors. Right? These are the colors that didn't match but do need to be there. And then this explains why it jumps to the next palette, because we're not able to put it in even though we should be able to fit it. And then that should fix some of the problem at least. So let's take a quick look. So the required additional colors is no. Nope, nope, nope. Why did it say there were 3? Because if it's equal, it's bench palette. I'm a little confused by that. Hold on. Match palette. So that's 4. So match palette count. That's right. So obviously it didn't fully match. We only matched the 1, which is the background color. So the required additional colors is, I mean, I guess it's not really 3 though. It should be, we matched this one. Oh, wait a minute. No. We're saying it's not -1, so it shouldn't have cared about this. Let's go back to this loop because something is not right. So we're coming in here and we're saying, okay, I wish there was some way to make this just remember what I want it to be all the time. All right. So the first color matches. Great. So the second color doesn't match. But it is a color. It's not -1, so that's great. Coming again, and it's a color. So it's 17, and then this is 18, and that's okay. So that's 2. And then why are you saying K is, wait, why is K 0? Why is K 0? It was not supposed to be. Zero here. Oh, because every time we match, we get out of K. Okay. So then it is actually supposed to be. because what we're comparing the final palette to temp palette rather than the other way around is what we're doing, right? Which, that's fine. So the 0E gets compared, and okay, so then the next thing we're saying is all right, they're not equal, but that's stupid. It's because of the way I'm comparing. So final palette hasn't been set. I really should be looking at what final palette has in it here too and say, okay, if final palette, ugh, that index is gross. I don't want to have to keep replicating that. So if this doesn't equal -1 and that, right? So final palette index, if it's not -1, meaning it's actually been set to something real and it matches, then that's one thing, right? But if it doesn't match, then we need another color. Yeah. Okay. So we get one match. That's fine. Great, so we match that first color. And it's like, okay, so we need one additional color. Second additional color. And then why is it doing it this way, though? Because we're incrementing J. So we're saying, okay, this compare the final palette to the temp palette. It really should be the other way around, right? Like we should be iterating through the temp palette. Because what's happening is we're going through every single it doesn't matter. 3 required additional colors. Well, that's actually technically right. So we didn't match it, right? So additional required colors is 3, match palette is 1. Three matched, 1 was 3 required, 1 matched, so there was so it's not really required additional colors, it's just the colors. That's actually not, that's not the right way to do it, or name it. It's not required additional colors. It's unmatched. Sorry to restart based on just renaming this thing, but it's like, it's going to help me later when I come back and look at this and be like, okay, so tell me why we're doing it this way. And it's the unmatched final palette count, right? Because the final palette is what we're comparing against it. So the final palette has 1 that matches and 3 that don't. But that's still stupid. Really should be the other way around. It should be like, okay, do the colors in the palette that I have match any of the... It's like a backwards way of tackling this. Or actually, no, you know what the problem is? This is the problem. I made a mistake with this, so I prematurely am jumping out of this. If the temp palette K isn't -1, jump out here, and then if we get out here and the match wasn't found, then we need to say right, like yeah, here we found the match, and that's great, but in this case we didn't. So and that'll cover the case of, like, it's not actually set in the final palette, so there's no match anyway, which is fine. That's why we're getting so many as part of the unmatched count. So there's the first match. We're good. The match was found, so we don't increment that. Now we're going to go through and we're just going to keep checking, because temp palette has more colors. That was the thing. We weren't going through, and that was what it was. I couldn't articulate it, but that's what I was having an issue with. I'm looking at this and I'm going, we're not actually traversing this whole. That was why I was like, why is K 0, right? And it's because we weren't traversing this whole palette properly. Actually, and you know what we could even do further? Well, we'll do that in a second. If this works, we can do that afterwards. So, not match found. Is that... Oh, I did this in the wrong spot. Okay. So while we're restarting this anyway, let's make the change that I was going to say. So, if it's one thing if temp palette has no real value in it, right? But like, if and just do this here. If final palette FPI is -1. Right, like if there's no value in the final palette, then just continue. Because there's no color to match, and there's no point in even checking because we're never going to find a match there. And so then this can go away because we're already checking that. That's a redundant condition check, which is unnecessary. Okay. So it's a real value. So that's good. Now we're going to check it against this palette. And it's like, hey, we found it. All right, great. So that's not unmatched. And now we're just getting a whole bunch of unmatched ones. But there's only one that we needed to check anyway. So the unmatched palette count is 0. This is -1. That's not going to work. And match palette count is set to what? Match palette count is that, and palette count is set to 3. Okay, and it's because my unmatched palette count thing is broken because now the logic that I had before was more correct. Which is that if the color doesn't match... Oh, but because I'm iterating across the final palette instead of the palette I'm looking at. So... How would that work in that case? In that case, we're taking the 0E and we're comparing it against 0E, and then it matches, and so then we go on to the FF, and that doesn't match against anything because we don't care about that. So, but the problem is that I really want to do the opposite, right? I want to actually say... I actually want to look at the palette that we have loaded and do something more like this. So if temp palette J, we're going to reverse the way we're iterating over this. So if temp palette J is -1, then we're going to continue because there's nothing to compare against. But if it's not -1, then we're going to calculate this FPI, and this should be K. And then we're going to say, okay, if this is -1, then let's not do that here. We're going to say, okay. So if this is final palette FPI is not equal to -1, if final palette, okay, then if the value is equal to the temp palette, and this would be J. So if the final palette is a number that's valid, I actually don't. Maybe, you know what? I don't even care. Like, does it match or not? If it doesn't match, if it does match, then great. We won't be checking for -1s on the temp palette. If it doesn't match, then we have our logic here that says if we didn't find a match, then unmatched palette count gets incremented because, like, we'll find a match for this one, and then we won't find it for this or this, and then we'll skip this, and then we'll say we have 1 match and 2 unmatched, and what would happen is you'd have 2 minus 1 here, and that would mean that we would need 1, wait, that's 2, the 2 unmatched and 1 matched, so that means that's actually wrong. It's just literally how many are unmatched, right? Well, if we have enough space in the thing, then do it. And that's still just 3. So that can go away. So then iterate through there and try and find, and it wouldn't be the background color because the background color would already have been matched, but just in case it is, we ignore it if it's the background color -1 for some reason. All right, let's try looking at that in real time and see what's going on. That may be it. So we're coming in here, we have our matched and unmatched. And we're saying, okay, temp palette has a real value, which is 0E at the moment. Final palette will have the same thing, so we're going to say we're gonna have a match found, and we break out of that, and then we loop back around. We're at our next color, which is 17, and it's not going to match at all. So now match wasn't found, so okay, that's looking good. So that's one match versus, so it wasn't a full match. So we can't use that. So if the unmatched palette count is less than that, which is 3, we can add the colors to the final palette. So we add 17, and we add, eventually we add 18. So I'm working on fixing basically the way that these tiles are getting loaded in is fine, and the way that it's processing the images is somewhat broken because of the color palettes that it's using. It was generating wrong palettes, which meant that the final output of the colors used was totally wrong. And I was trying to figure out why. I thought it was going to be a quick thing. It turned out to be a lot more complex. All right, so I think we've updated. So that's our found palette index, so we're happy with that. And then we re-index, and the next thing we're going to do is grab the next palette, which is E0E0C. So that should just say that there were two matches, one match, one unmatch, if I did this right. So we have one unmatched and one matched, and the palette count is bigger than that. So now we say, okay, well, let's add the palette color that it couldn't find to the final palette. And we will eventually get to a point where we add it over here in the memory. Okay, so now the palette is correct without jumping to the next palette. Okay, and so then once that's done, we will re-index the image with the new colors, and then let's see, it should find all the colors this time, because it's, let's see, those 3 colors are in the palette. There's one matched color, there is 2 matched colors, and there is, we're about to have 3, so we've matched 3 colors, and then that's it. And so the match color count is 3, the palette count is 3, and it's like, yes, we found it, okay, cool. And then we index everything with the new colors, and we're going to get the new palette again, and we should just wind up in here again. We do. Cool. And then we did that. And if we load that, hooray, that actually worked. Okay. So finally, we have something that drew that correctly. So now, let's take something a little bit more. Let's take something different as a sort of test example here. Let's do that one. So we'll export that, and let's make sure that that metatile gets generated with the right palette. Save that out, and then load that that looks correct. The image looks a little different, but I think that might be down to... That might be down to just a weird color choice or something. But... Oh no, that's actually exactly right. Okay, cool. So it generated our palette with 3 gray colors in the background, black color. So that's not even using all 4, but that worked. Let's choose something a little more complex. Let's go with like that turret. All right, let's rerun this and reprocess again. And that is exactly right. Which means that now our metatiles are correct. All right, so the next thing I wanted to do, once we got past that, you know what? Let me run one more quick test because I'm paranoid now. Since it took us this long to get here in the first place, let's grab this house and we'll just put the whole shebang right there. And then we'll put this green there. You know, it's... The maps themselves aren't really the hard part. I mean, there are challenges there, but the bigger challenge is dealing with the color data for stuff, just with the NES being so limited in what it can do in terms of color usage. That has been a constant sort of thorn in my side since the beginning of all of this. Specifically because of the colors being different, and then also the attribute grid of the backgrounds where you can only use one palette for each of these red squares. So it's it is very frustrating. But it looks like we have successfully fixed the problem. That's the bottom of the house with the green color. That green is so weird. I can't believe that's the closest thing that we have to the green that Jordan used, but I guess that makes sense. A quarter or just like, well, yeah, I mean, and then you can only really use 3 or 4 at a time, right? So it's like all these weird limitations with the way that it works, but that's all looking good now. Okay, cool. Well, that was something. So the next thing I want to do is, so ideally what I want to do is get rid of this section here now where it's hard coding the metatiles in. So let's look at where that is. Okay, so it's actually loading this into this structure and then looping through and loading in the individual metatiles in the project files. So what we would need to do, that's not so bad. What we would need to do is, let's put a note down for next time, because I'm going to end the stream. This has been, we're at 2.5 hours. This is one of the longer ones I've done in a while. So what we need to do here is remove this code so that the metatile information is no longer processed from the JSON, rather it's loaded in the load map code to using the generated metatiles. Using generated file names and should correspond. Okay, so that's our note for next time, hopefully Thursday, where we will go through the process of taking this out and changing the code that we were just looking at to instead use generated file names, and then update that structure with the file names of those metatiles. And then update the map data to map to these metatiles. I've never seen how to use the memory viewer to examine arrays quickly, so I learned something. Oh yeah, I've been using Visual Studio for a while, and yeah, that's one thing that makes it so invaluable. The debugger is really, really good, which is also incidentally why I think Messen is so good, because forgetting for a second about how broken my stupid game is. It's not stupid, it is broken. He's kind of done a lot of work to make it work like Visual Studio, so it's kind of neat to be able to use the same keystrokes, and if you have a variable, you can, do a lookup of the value or the address, and then when you have the address, you can just put it in here. You can go to, a particular address, like whatever, 30, and kind of watch it in real time. So I really appreciate the debugger in Messen, because it's so similar to what Visual Studio provides you. Being able to view the memory in real time like that is so helpful when you're dealing with complex data structures, or even just large data structures where you can kind of page through the hex. So anyway, that was a lot longer than expected, but made good progress and fixed that bug, so that was good. And we'll continue on Thursday, but as always, thank you for watching. If you have any questions, you can feel free to reach out to me on Twitter at Clearvis. I'm on Video Game Sage as Zelius, and I'm in the chat usually. A lot of people have hit me up there when beginning their NES Dev journey. I am by no means the be-all end-all expert, but there are a lot of excellent people on there who know a lot about NES Dev, and you should go talk to them because they're super cool. And I'm there sometimes too when work and time permits. And yeah, and I am still working on Zero Pages episode 6. Sorry for the delay there, but that's how that goes. Video editing is so time consuming, and I've restarted parts of it because I was not happy with the direction that I was taking it in, and now I have a better idea of where I wanted to go compared to where I was. It was a lot more just kind of reference before, and then I realized that I should tie it into the Hello Mario and Hello World episodes, so I've had to redo some of that. But anyway, question. I watched your Hello Mario video and you were talking about setting up the code to tell the ROM what it would be. So could I put the ROM on a real cartridge similar to the NES? Yes, you absolutely could. So in addition to using something like the EverDrive for your ROM, let me go back to this for a second here. So the question appears, I don't have the video. I don't have the video anymore. This really nice guy named Eric reached out to me. He's an electrical engineer, and he took the Hello Mario and Hello World ROMs, and he built a he built an NROM board, and he actually programmed some EEPROMs with the ROM, and was able to make them display on the NES. The one thing that I didn't do in the Hello Mario video properly was that it did not clear out the name table, the background, and on the real NES that will have garbage in it if you don't. So like Mario appeared, but there were also just random tiles in the background, so I had to give him a modified version of that to display properly. But yes, this is absolutely something that you could load onto an EEPROM on a custom PCB or just on an EverDrive. In fact, I've tested a few things with this multiple times on my EverDrive, on a real Nintendo, and it's pretty awesome to be able to do that. I can even show you. I think I've shown this before, but if not, I'll show it now. It's this really, it's an old screenshot at this point, but it is, I was looking at the player sprite on top of the water and discovered that on the real NES, two things. The player sprite, while it looks super cool on an LCD or played through the AVS, because the AVS is able to display super crisp pixels, on a CRT, it's really not. Even through, I guess I never tried through component. I suppose it's probably possible to do. Why is this not working now? Let me see if I can find where I posted this picture, because it's really interesting to see if you're asking about putting this on a real cartridge, which is the the goal of this project. It's really cool to see it working on a CRT. If I can, yeah. Cool it. All right, yeah, you can open it that way. So, where is Windows asking me how I want to open that? It's not. Why? Where did that window go? There was just a window asking me how I wanted to open a file. And it is gone. When are you back for more questions? I do Discord, yeah. So I'm on Discord as Clairvis, although on the video game Sage Discord, I show up as Zelius. Where the hell did that go? There it is. Sure. Can this open it? Yeah. So this is a picture from a CRT, and it's like super close up, which doesn't help the clarity any better. But you can see like even with a clean picture, very fine details like on the ship are lost because CRTs are just not that precise. But yeah, that was totally playing just on an EverDrive through. It's actually my wife's NES. It's not mine, because long story short, mine got lost overseas after leaving it there for many years. So, but yeah, the Chrysodrop. I don't know that cart. That one, I'll take Matt's word on that one. Matt knows what he's doing, so If you haven't seen, Matt has worked on and released a game called From Below recently. It's really cool, and yeah. So I don't know that cart, but if he says it works, I will assume that it works. I got the EverDrive just because it has a lot of mappers that it supports, and I wanted to be able to test on that, knowing that a lot of people who will have the ROM version will probably have an EverDrive. So yeah, hit me up on Discord. I'm there. I'll try to answer as quickly as I can. I can't always answer right away, obviously, but yeah. But yeah, so or you know, if email works too, you can hit me up at zelius@gmail.com. Some of my contact details are in the video description. I'll post this. I post all these videos on YouTube for people to watch later, obviously. Yeah, so thanks for watching. Thanks for coming to hang out with me. And hopefully Thursday we'll continue this. And I will see you guys next time. Have a good night or morning or whatever time of day it is for you, since people are generally around from all over. And I'll catch you next time.